The Earth is a complex and dynamic planet, composed of several distinct layers that each play a crucial role in its overall structure and function. Understanding the layers of the Earth is essential for comprehending various geological processes, including plate tectonics, volcanic activity, and the creation of mountains and earthquakes. The Earth's layers can be broadly categorized into the crust, mantle, outer core, and inner core, each with its own unique characteristics and composition. Starting from the surface, the Earth's outermost layer is the crust, which is the solid, rocky shell on which we live. The crust is relatively thin compared to the other layers, varying in thickness from about 5 kilometers under the oceans to around 70 kilometers beneath the continents. Despite its thinness, the crust is incredibly diverse, composed of a wide range of rocks and minerals. It is divided into two main types: the continental crust, which makes up the landmasses, and the oceanic crust, which underlies the ocean basins. Continental crust is generally thicker and composed mostly of granite, while oceanic crust is thinner and denser, made primarily of basalt. The crust is also the layer where tectonic plates are located, and their movements are responsible for many geological phenomena, including earthquakes, volcanic eruptions, and the formation of mountains. Beneath the crust lies the mantle, a thick layer of hot, solid rock that extends to a depth of about 2,900 kilometers. The mantle is composed mainly of silicate minerals rich in iron and magnesium, and it makes up about 84% of Earth's total volume. Although the mantle is solid, it behaves like a very viscous fluid over long periods of time, allowing it to flow slowly. This flow drives the movement of tectonic plates in the crust through a process known as mantle convection, where hot material from the deeper mantle rises towards the surface, cools, and then sinks back down. This circulation is a key driver of plate tectonics and is responsible for the constant reshaping of Earth's surface. The mantle is divided into the upper mantle and the lower mantle, with the upper mantle including the asthenosphere, a semi-fluid layer upon which the tectonic plates move. As we move deeper into the Earth, we reach the outer core, a layer that extends from about 2,900 kilometers to 5,150 kilometers beneath the surface. The outer core is composed primarily of iron and nickel, and unlike the mantle, it is in a liquid state. The high temperatures and pressures at this depth cause the iron-nickel alloy to melt, creating a convecting fluid layer. This liquid outer core is critical for the generation of Earth's magnetic field through the dynamo effect. As the liquid iron in the outer core moves and flows, it generates electric currents, which in turn produce magnetic fields. These fields combine to create Earth's magnetic field, which extends far into space and protects the planet from harmful solar radiation by deflecting charged particles from the sun. At the very center of the Earth lies the inner core, a solid sphere composed mainly of iron and nickel. The inner core has a radius of about 1,220 kilometers and is under immense pressure, which is so high that, despite the extreme temperatures, reaching up to 5,700 degrees Celsius, the iron remains solid. The inner core is believed to rotate slightly faster than the rest of the Earth, and its interactions with the outer core contribute to the maintenance of the magnetic field. The solid state of the inner core, despite the high temperatures, is due to the enormous pressure exerted on it by the layers above. The study of these layers has been made possible through indirect methods, such as the analysis of seismic waves generated by earthquakes. As these waves travel through the Earth, they change speed and direction depending on the material they pass through, allowing scientists to infer the structure and composition of Earth's interior. This knowledge has been crucial in understanding not only the physical structure of our planet, but also the dynamic processes that have shaped it over billions of years. The interactions between these layers drive many of the natural phenomena we observe on Earth's surface. The movement of tectonic plates, caused by the flow of the mantle, leads to the creation of mountains, earthquakes, and volcanic activity. The heat generated by the inner core and the movement of the liquid outer core are essential for the existence of the magnetic field, which is vital for protecting life on Earth from cosmic and solar radiation. In summary, the Earth's layers are a testament to the complexity and dynamism of our planet. From the solid crust where life exists Down to the fiery inner core, each layer plays a critical role in maintaining the conditions necessary for life and shaping the planet's surface. These layers are in constant interaction, driving the processes that make Earth a unique and ever-changing planet.